All right, here we go. So first question I'll bring up on the board. You can simply just write it down, maybe come up with your own type of questions, but here we go. So if we let f of x equal 2x, oh, good question. I'll get to that in just a second. And g of x equal to 3x plus 1. All right, yes, this is a function f. There are two things you need to realize. One, this is a regular variable f. All right, that is just a variable that we know that represents something that's unknown to us. I love when people say, I knew math up until they threw letters in there. You've been doing that kind of math since kindergarten. Your math just looked like this. So instead of seeing 2x plus 1 equals 7, your math was 2 square plus 1 equals 7. Or in kindergarten, it was 2 fishies plus blank fish gives me really bad fish over here, apparently. 3 fish. This is literally what they present in kindergarten. Instead of an X, they just left a blank. How many fishies go there? Just 1 fishy, right? 2 fishy plus 1 fishy gives you 3 fishies. That's literally how they teach it in kindergarten. Then we get a little bit further and we put a square or we put a triangle or we put a little question mark for you to figure out what the number is. And then to simplify even further, when you got into algebra, we just put a letter there, right? So a letter wasn't there to confuse you. You just been doing that kind of math this entire time. So when people say, I used to know it until letters came in, you've been doing it with letters your entire life. All right. Now, with that being said, f just represents a regular variable, but then a function f looks like an S with a line through it. All right, just it gives you a name of the function. Go ahead. It's the name of a function. Oh, the point of it is so we don't get confused between functions' names and variables that are being multiplied. If you went up to a mathematician and you wrote this out right here, they're going to do f times x. So that looks like a variable, and then in parentheses, another variable that needs to be multiplied. When you write it in this sense, then we know, all right, that's a function's name f, and we're going to have the letter in it. So it's going to be the letter x. That's going to be, so it's function of f of x. It's just the name of the function and what is the actual variable. So you might see it like this as well. Some people will use h of r. H is the name of the function. It's kind of like almost like writing a cursive letter. And then r is the variable in the function. And this is how mathematicians write it. So when you go to your next step, this is how they're going to show it. I do not count off if you write a regular f. You're writing your information down. So just note that. Any other questions there? That's good. That's good. All right, so there's your f of x and g of x. I'm going to erase all this. Just this part here where we talked about it. One other thing I love when students ask is, should I write this down? If I write it down, you should probably write it down. I know this math. This is not for me. This is for you. If I write it down, or I might indicate like maybe not write down the fishies, right? You don't need to know that. But if I write it down as a note, it's important, and you might see it on the quiz or the test. This comes up. All right. Any questions so far? All right, ask. Don't be intimidated. That's what last class said. All right. So my question is, you know what? Let's see if I can do better here. Are these functions a linear transformation? One thing you'll learn about me, I don't have the best handwriting. So if you don't know how to read it, please let me know. I don't mind explaining what I just wrote. Yes. I have it scheduled in 3 weeks, 3 to 4 weeks actually. But I want to throw in a mid-unit test or like a quiz halfway through it just to see where you are at. But things might change. It just really depends on your content, the level of your content. I'm not going to give you a test if I feel like 0% of you are ready. If I feel that majority of the class is ready to be assessed, that's kind of when I give a test. So I schedule it in my head about 3 to 4 weeks from now. And I feel confident because I had a really good Algebra 2 teacher last year. All right, so years prior, we didn't always have the best. So I had to teach a lot more. But it just depends on where we're at as a class. And you're kind of blended in with fifth period. So as those combined classes. But I have a schedule for 3 to 4 weeks. But my tests are not set in stone. My dual credit, they're set in stone. But for y'all, it's just like I said, it's us where we're at. I'm not going to give you an assessment if I don't feel like you're ready. But if I feel like you are ready, then I'll assess you. Any other questions there? That's good. All right. So when you think of linear transformations, what questions come to your mind? Linear transformations, like what is it? A graph. What kind of graph? X and Y coordinate plane graph. All right. What do you see on this graph? Lines. I like that. Oh, you're already speaking some good language there. Transformations have 3 different titles. What's a net? That's an equal sign, by the way. What's another word for reflection? Think of oh, my bad. Another word for mirror is reflection. Sorry. So if you think of like geometry and stuff, reflection is one type of transformation. Can anyone name me the other two? Don't think of like rotation. That's more geometry. But for transformations, reflection's one of them. What are the other two? That's reflection. That's perfect. What if I just, huh? You're thinking geometry. So I think it's rotation, reflection, and I don't know what that, but that's geometry. That's one. Dilation's another one. Dilation starts with a D. All right, so reflection, dilation, that's really good. What if I'm here? And now I'm here. What did I just do? Now I am technically, okay, I like that. I like that one. This way. So it's a type of transformation. Pretend I'm a line. I'm a line here, and now I have moved here. Well, think of it like this. You can move left, right, up, or down with it. So I could take some, huh? Oh yeah, like a little analog stick. I like it. Anyone else? I'll give you a hint. Starts with a T. Not transportation or transformation. I like that. What is it? Travel. Okay. Any others? Huh? Translation. There it is right there. So these are the 3 main transformations you started to see in Algebra 1. They went further into detail in geometry, further in detail in Algebra 2, and then we get to pre-cal and we assume you remember these things. Well, I've learned a lot after trying to assume things, so I try to reflect on what you need to know prior going into it. I do want to back up to linear. We talked about lines. What type of lines can you describe for me that linear lines made? There's 4 of them. Can you tell me what type of line this is? It is a diagonal. It is relatively straight, depending on how you're looking at it. I'll graph the other 3. Can you tell me them now? Horizontal has a slope of what? Yeah. It doesn't matter. It doesn't matter. It's just the direction it's going is what you need to focus on. Huh? So what was that? So we have horizontal. That's great. That was one of them. This is this guy. But can you tell me what the slope of a horizontal line is? Very good. I heard the other one. What was the other one? Vertical. Can anyone tell me what a vertical line has? Undefined. Very good. If it looks like a Z, and it should be a equal sign, it is. So undefined. M equals 0 for the horizontal. M equals undefined. Well, let me just back up this a little bit. We know what M represents, right? Slope. Okay, cool. All right, what are the other two? Sorry, undefined. It got a little messy there with the. Hey, they are diagonal lines. I will not argue that. There it is. A positive and negative slope, right? So this was positive. How do you read a graph? Very good. Just like you read a book, left to right. So as I read the first graph here, I see that as I move from left to right, it is going up in a positive direction. As I read this graph from left to right, it is going down in a negative direction. Kind of recalling some linear things. All right. So that's basically what you were supposed to have learned. Let's go into a little pre-cal. If I want to know if a function is a linear transformation, this part is important. That's supposed to be a star. I'll try that again. A little bit better. All right, here we go. 2 facts you need to know. By the way, pre-cal's full of proofs, so we're getting right into it. I have to prove that f of x plus y equals f of x plus f of y. This is the first thing you have to prove. The second thing you have to prove is prove that f of kx is equal to k times f of x. We're going to talk about how to prove these 2 things. We good so far? What you got? Is the red just scared you? You were good with the blue, huh? Red just got you. Let me do an example and see if that works. What did I say f of x was? At the very top, first 2 things you wrote, 2x, right? Okay, let's start with this one. The first thing I want to prove is I want to see, does f of x plus y equal f of x plus f of y? Yes, you see lots of letters here. You've already been told what f of x is. I need to figure out what f of y is to be able to prove what f of y is. If I want to know what f of y is, what's different between f of x and f of y? The x and the y. If I replace this x with a y, what am I going to replace that x with? So then f of y equals what? 2y. So equal signs are. Go. Are we good with that? So this is kind of something what you learned in algebra. You first start off with like, if f of x equals 2x, what's f of 3? And you went 2 times 3, right? You replaced the x with a 3. And then you got into a little bit of algebra 2, and you found out that f of x equals this. So f of a might be 2a, right? Now we're going to take these concepts and go a little bit further. So before I move on, does everyone understand how I got f of y equals 2y? All right, if I replace whatever I place this guy with, I replace that guy with, right? So if I want to make this super complicated, you don't have to write this part down. But let's say I wanted to find out what f of 3x squared plus 2x plus 1 is? Hypothetically, I asked you to find this. What would I do? Things can get hard, look harder, but the concept doesn't change. If I replace this x with a y, I replace this x with a y. So if I replace this x with 3x squared plus 2x plus 1, I'm going to replace x with what? The exact same thing. So the 2 was already there. So I just write that down, and then I replace x with it. So that becomes 3x squared plus 2x plus 1. No matter how complicated it looks, whatever's in parentheses on the left side, you literally just replace the x on the other side. Right? Don't stress about it. This is just an example. It was 2x plus 1. All right. But no matter how complicated it gets, that's all you have to do. So with that concept, let's start off with the proof. What then is f of x plus y? We just talked about f of x is equal to 2x. F of y is equal to 2y. I just showed you that really super complicated one. What is f of x plus y then? What's that look like? If you wrote that complicated one down, how can I make it look like this? Sure. Think about it. Close. You're missing some crucial symbols. Would it? Not quite. Here's one. Hannah, Jason, Sarah, Serene, last name Gomez, Miranda, Ashlyn, Holly, Leanne, Jaden, Joel, Joel. Oh, okay. Avery, Tess, volleyball. Katie, Hayden, Ashton, Kate, how do you say that? Callie, Caden, Marlee, Benaya. Anyone else I did not call? Sorry about that. Okay, so what crucial symbols am I missing? Y'all were talking about it. What is that? Oh, what is that? Huh? What is it? Parentheses. So that's what is that what you said? Okay. Hearing. Right. So I need parentheses. And then in that parentheses, what would I write? X plus y. So if I'm replacing this x with x plus y, then it becomes 2 times just like that. So again, all I did, if I replace this x with a y, I replace this x with a y. So if I'm going to replace this x with an x plus y, I'm going to replace this x with an x plus y. No matter how complicated it looks, I'm literally just going to replace it. But why would I use parentheses? To separate it, to indicate what kind of operation. Multiplication. So I have to separate this. If I don't have the parentheses there, then all I have is 2x plus y. Where's the 2 being applied to without parentheses? Just the x, but it has to be applied to everything I replaced x with, just like it was here. All right, so we good on plugging in. So whatever you see here, no matter what it is, replace x with that, no matter how complicated it looks. Exactly. We all good now? Now let's use our algebra skills. How do I simplify this? Nah, I can't combine yet. Well, technically one's an X, one's a Y. Ooh, not cross multiply, but you have the right motions with your hands. Not factor. Huh? Distribute. Very good. You would want to distribute. Distributing is the same thing as what? Multiplication. Right? So you got the right idea. We're just going to use the correct vocabulary. We'll get to that point. So 2 times X is 2X. And then 2 times Y is 2Y. How we doing? Okay. It's coming back. I know. First day off the bat, you probably were not thinking that you were going to have to do math today. Right? At least what last period said. All right. But we only got 150 days left. We got so much to cover. Right? And then you're out. Only 150. All right, here we go. So now looking at the information that I have supplied and what I have come up with, what does 2x equal? F of x. All right, so I can replace that. Go ahead. Yes. Yes, ma'am. Oh, I'm sorry. So this right here is a variable f to indicate an unknown, but this right here is a name. I don't care if you do it that way, but if you get into your other math professors and stuff like that, that's how they denote it. All right. Okay. So that means that this 2x is equal to f of x. What do we know 2y is equal to? F of y. So that means that f of x plus y from the very get-go equals what? Perfect. You have proven the first statement. Right? That was the first thing in red in the previous slide that we had to show. So you asked, how do I prove things? Remind me your name again. Kane? Okay, so you asked me, how do you prove? So I proved this first statement by figuring out, I was already given f of x. I went to go find out what my f of y is so that when I start plugging things in, I can bring it back to replace it to see, does it actually equal that? So that's a first part of the proof. All good with that? Now we got to do the second part of the proof. By the time we get out, 218. All right, we're all good? The second part you had to prove was that f of kx equals k times f of x. That was the second step. So just like we've been doing this entire time, what is, so if I come over here, I'll prove it as this. What is f of kx? If f of x is this, 2x, what is f of kx? Yes, sir. How so? Tell me, what does it look like? Parentheses. Perfect. So this becomes 2 because the 2 is already there, parentheses kx. All right. Again, just like I've been doing this whole time, if I replace the left side, I replace the right side. Now, do I need the parentheses in this situation? Why or why not? Would I distribute in this situation? No. Why? Perfect. If you recall from algebra, distributive property applies when there's a plus or a minus inside the parentheses. If you ever forget these steps, just plug in numbers until you can recall it. Let's look at this. 2 on the outside, and let's say 3 and 4 on the inside. right? What does PEMDAS tell you to do? What's the P part? Parentheses. What is the inside the parentheses telling me to do? Right to the next one, but inside the parentheses, what's it telling me to do? Multiply. So what's 3 times 4? 12. So then I would get 2 times 12. And then that becomes what? 24. If you try to distribute, this would become like this. And if I did that, that would become 6 times 8. Is 6 times 8 24? No. So we do not distribute unless it's a plus or a minus. So if you forget these type of rules, just plug in numbers until you can remember it. All right, but there's another part of this question I want to ask. So you just said we don't need the parentheses. So now I got something like this. When multiplying things, does the order matter? What's 2 times 3? What's 6 times 4? Okay, let's flip that. What's 3 times 2? And then what's 6 times 4? 24. So when multiplying, does the order matter? No. So do I have to write it as 2kx? Could I write this in a different way? And then why? How would I rewrite it? Why? Well, that'd be going backwards, right? We'll be going back to that spot. So I wouldn't want to put the parentheses back there after I just got rid of the parentheses. No, you're good. You're good. Just thinking the process out. Yes. What order would I want to switch this in and why? Yes. And how so? What would I look? How would it look like? Not plus. Multiply k. All right. So you put the k in the back. Not wrong. But remember what kind of proof you're looking at. What do you want to go first? So how would you want to rewrite it? Perfect. So in proofs, the thing you got to remember is where are you heading, right? Use that as a guide, right? If I know I'm trying to get to Shepherd, then I know I need to take certain routes to get there. Knowing your end goal will tell you how you want to organize your routes. All right. So I saw the K's in the front here. So it's in this order. I want to put the K in the front here. All right. Now, by doing this, what do I see? What do I see that 2x is equal to? F of x. So I can replace this and say now this is K f of x. Have I just proven that f of k of x is equal to k times f of x? Therefore, f of x equals 2x is a linear transformation. Now you might be thinking, I did this for a yes or no question. Yes, you did. However, I grade the work, not the answer. So make sure you show all work. Now, after seeing it for the first time, you are experts, correct? Let's do another one. What was the g of x function I gave you? Before I get into this, let's back up just a little bit. Are there any questions on this? Look a little bit easier than how it was said beforehand. The more you do this, you'll start identifying some patterns. I'm not going to tell you what those patterns are. You identify them yourself, and I'll tell you if you're right or wrong. That's what makes math beautiful. There's patterns all around it. Right? All right, so there we go. So 3x plus 1. I want to see if this is a linear transformation. What's the first thing I got to prove? I'm good at awkward sciences. I'll just stand here and stare at you. Okay, but so what am I proving? What are the two things I had to prove? Perfect. All right. So just like that, but instead of an F, what do I want to call it because of the notation? A G. Perfect. So the first thing was what? Read it to me. Okay. Equals what? Perfect. And just an FYI, that's read as G of X. So we don't have to write the parentheses, but you're good. You're good. Same notation, same purpose. To prove this, what was the first thing I did? What I had to go find first? Not quite. I can't use the like thingies quite yet. So in that first step on the previous problem, look back. This is what I was trying to prove. What did I had to go figure out first before I could just plug in? I heard it. What? Not just specifically the Y, but the G of Y, right? I got to figure out what the G of Y is. If I don't know what G of Y is, I don't know if it's going to equal that or not. What is the G of Y in this situation? Perfect. Just like before, even though it looks slightly different. If I replace this X with a Y, I replace this X with a Y. So this becomes 3Y plus 1. We good with that so far? All right, so now we start our proof. I start off with the left side. G of X plus Y. What does that equal? Close. We're missing something. 3 parentheses, and what's going to go in the parentheses? X plus Y. Am I done there? Or am I forgetting that plus 1 that was there? Okay. How we doing? Okay. Okay. Now we distribute. Now we bring in our algebra skills to start simplifying. Perfect, because the 3 would only be distributed to the what? Perfect. So that becomes what? That's a plus sign, by the way. All right. What do you notice? 3y plus 1 gives me what? G of y. Am I able to turn 3x into G of x? Yes or no? Why? There's not a second plus 1 for me to combo. Yeah, so it'd be like 3x and then plus this. So does G of x plus y equal G of x plus G of y? No. So therefore, it fails. If it fails on this side, you don't even have to go prove the other side. Make a little bit more sense? You think you're ready to try one? I think you are. I'm going to give you 3. One easy, one medium, and one super, super hard. No, we don't. Don't lie to me. I'm going to write it down anyways. Challenge to yourself. Yeah, I'll put all 3 of them on there. And you can just play with the easy one at least. Linear transformation. Sorry, the top, my bad. Also, it's like right over here. Wishful thinking. Does linearity hold? Linear transformation is what we're specifically going into. All right, so here's the 3 you can try. I challenge you to do it at home, but you do not have to. We'll start our lecture right here. So that's 2x minus 3, or h of x equals 2x minus 3. P of x equals 1/2 x. And here's the challenge. G of x equals x squared. I know we only have 2 minutes, but challenge yourself. Go ahead. Oh, it's just another name. So like F, G, Q, R, it's just the name of the function. And we try to put it in cursive, but I don't really know how to do a, listen, this is a cursive P. I don't know. Pretend that's the name of it. Go ahead. Completely up to you.